Hello everyone, welcome to part 3. Today, in this video, I'm going to, we're going to look at some computer logic, and basically, this season, this podcast, let's just call it, just call it a season. This podcast that this video is on right now, the logic one, is one out of I don't know, 5 or 7 or 6 or something. I don't know how many I'm going to make. For each topic, computer based. So this is the stupid the Clipton adder that didn't work. No, what was it? The 1-bit register or something. Yeah, the 1-bit. It was either the register or adder. I don't remember. I'm just checking phone recording. Anyway, so I'm just gonna build a diagram out of blocks based off of uh like a basic block diagram of a computer in action or whatever. We go to a different color concrete to represent different things. That's good. I already got that one. Got that one. Let's do this one. So let's say we have a RAM. I'll do this in a fashion, in a way that I sort of got to do it in a similar way to this. To how I'm doing it right now. I didn't. Well, I kind of copied him, but it's a really good way to express how it works. So This is basically what he did. So let's just say that let's just say that the green part is the lines. Okay. This is how he did it. It's a really effective way, and I like it. Let's say this is the RAM. So we have the memory, the random access, random. We have the RAM right here. What the hell? We have the RAM. Stop. Okay, there we go. We have the LU. So basically, well, yeah, this is how I'm gonna do it. So, there's no point in this, but I'll do it anyway because I've already started doing it. So, anyway, usually it's registers here, but I don't have the amount of time right now. I don't know if my mic picked up what I said before. I did say that, but I don't think my mic picked it up. I don't know. If I said it twice, let me know by leaving a comment. So we have the ALU, the part of a computer, the arithmetic logic unit that that does all of the math. It's the brain of the computer, and these repeaters symbolize which way the signal's going, so it goes in a circle. So I could do So there could be something stored in the RAM. Just call this RAM/registers because usually it's ALU and two registers, or like ALU and a register. It just acts. It will do that. RAM being random access memory, just memory that it's it's memory that temporarily stores important data for the CPU, and then the register is that works with the ALU to store values of numbers. So say there's like two numbers like 1 and 4, for example, in the stored in the RAM/register, and you want to send it to the ALU to get added. 1, 4, 5. So then it would output a 5 into here. You can read again. It's like a basic diagram. I like this. I like the way of doing this. I won't copy exactly what it did, but we have like this way in his video. He put like little different colored thingies here, explaining like this is the register. It lets. You probably don't know. It lets it lets when there's like a clock pulse, it lets like current through whatever. I'm just a bit stumped. I'm a bit tired. He's like, you have these parts here. They're called the registers, and when there's a clock pulse, it lets the current through. Like if there's a current going through it, and I don't understand how that makes sense because if you have multiple things building off here, it's all gonna go. If this outputs to all of them, then you unlock it. All of them get powered. I don't understand how it's supposed to select a different one, but don't blame me for this. Blame the other guy or whatever. I got a lot of time. Anyway, gotta fix my mic. So I'm just gonna call these latches, and then this is the display. So you have latches, and I don't want to make a mess, but when there's a clock connected, a clock is like a thing that cycles on and off, on and off, on and off, on off, on off, 1 0 1 0, 0 1 0 1, and it inputs, and it's like every time it gets set to one, that means it's on. So it can control the speed of anything if it's going in a circle. So if I didn't have a clock pulse thingy set up, I had a value in here and went in here, it will keep going in circles too fast. If I had a clock pulse, every single time it ticked, it will let it through. Every time it ticked, it will let it through. Every time it ticked, it will let it through. It's like to control everything in the computer. And he says that that's what allows things to go through different things. Like allows data to go through different, like these, which he called the registers, but I'm gonna call them latches because that's more simple to understand. So just build off a bit more. These light blue parts being, and the green parts being the buses or the wires. Light blue parts being latches to let whatever through. And orange will be the clock. I don't feel like building any more than this clock. And if you want, so if you have like lines, obviously it's not going to be just one line leading everything. It needs a bit more lines to store more values and more things. So in that case, we could just connect this to here. Oh, what the hell? Just connect this to here. This wouldn't interfere. So like, it can't go this way. It can't go back into the clock. So go through here, and then it can connect to everything through this. Oh no, you can just connect. You connect the clock to everything. You can how I did it. Connect the clock to everything separately, or connect it to all the buses that are connected to things like other things. So in here, right. I will do ROM. ROM will be right here. So this episode is like explaining if parts of a computer and how they work. The ROM, read-only memory. It's the memory that is stored in the computer that you can't change. It's just there. It's just a program that's there. I keep checking how long I've been recording for. If I am even recording for the whole time. So read-only memory. We could do another one here for RAM. No, I already did RAM. No. This can be the registers. This over here can be RAM. Because you don't use RAM with an ALU. You use RAM with the CPU. Even though the ALU is part of the CPU, doesn't mean they connect the same based on what they work with. So the ROM. Random access memory, I already explained it. Stores, temporary data for the CPU and stuff. ROM stores information like data about for the how when you turn on a computer it has like a startup screen. All those startup screens are programmed into ROM that gets displayed through the display. So in that case, these two will be like this. So what the hell? Yeah, that's right. We'll do this to indicate both ways. Okay? 4 ticks equals both ways. Just symbolization for it. RAM, ROM. What else is there again? Yeah, we need an interface if we want to control it. So we'll do a red part, interface. Like the control center of the computer. Like if you're on a laptop, it'll be a keyboard and mouse, going into the back of the front of the computer. If you know what I mean. Can I spell? Boom. And then this one be moved back. We'd have a thingy here. Then the interface. Then both being the same color because they have the same purpose, origin, whatever. You have the interface here. Then the interface driver. At least this is how I imagine it. So you'd have just every signal going through here from the interface. This controls what gets into the computer and what doesn't. That's just how I imagine it. Do this. Then this happens to everything. So you can control one of these, so you can hook up another bus going down here. So we can make a signal go out here. Should this go both ways? No, it shouldn't. At this point, it shouldn't. They should be blue. So all the light blue parts in this case will be connected to the clock. Okay, the latches should be connected to the clock, which are the blue parts. That's it. Let's do the move back one. What else is there? Oh yeah, there'll be a separate. I do have time. Okay, I'll explain some. Okay. Just mute it for a sec. Let's talk about some registers. Talk about 4 different ones. So we have, I don't know the purposes, like the main purposes for all of them, but I know basic purposes, and I can give you ideas. Like I said, I'm just starting to do stuff like this as a feature, so yeah. So first of all, we have so as I said, registers work with the ALU. That's what you need to know. But only the normal ones do. The other ones do different stuff. You have shift registers. Reading my book here. Shift registers can be used for displaying numbers with 7 segments. They take the value from the ALU, store it, save it, and then you can read it. It shifts this data when you are trying to add a value to the place over. And then you have barrel registers. A barrel register is a type of register that can cycle its outputs in a circle. They are used in computer logic, and I don't know where. I've never seen a barrel register. They're not really useful, I guess. I don't know. Then you have one of the most important ones, instruction. IR, instruction registers, hold inputted instructions, then tells the computer to follow them. Useful for inputting important information for the computer to follow. So it's like input any value in binary, ones and zeros. In the next season, they'll talk about binary and computer code. But this just doing an overview of it, so you guys understand it. And so this episode's almost over, and then I'll upload it, and then that'll be it. So yeah, it's like the basic, diagram I built today. Overview of basic computer logic. I just want to say a few more things before episode ends. The future seasons will be future podcasts is where I'll actually do parts of building a computer in this single player world, or in a multiplayer world if you want me to. And the first couple seasons, you just like overviewing. So in this one, overviewing the parts and what they're used for. Just that's basically what we're doing at the moment, and like logic like this, you know. Then season 2 will be. I haven't even done one episode of. This is still season 1. Season 2 will be like binary and like computer maps and stuff, and who's complement all this stuff also needed to know. And then once I've gone through everything you need to know, then we'll start making them in Minecraft with Minecraft Redstone. So, subscribe. Make sure you guys subscribe, like. Make sure you guys like and comment